Okay, so now we're starting chapter 6, and if you recall from the very first lecture, in chapter 6, we are starting the second type of statistics, inferential statistics. In the first one, confidence intervals, we're going to use confidence intervals to estimate an unknown population parameter. Now we can do confidence intervals for the mean, for population proportions, or for variance and standard deviation. In this class, we're going to just look at these first three population proportions. So first, in section 6.1, we're going to see how to find a confidence interval for the mean when we have a large sample size. So the first thing we need is a point estimate. Point estimate is kind of like that starting point for our interval estimate. And the most unbiased estimate for the population mean is the sample mean, x bar. We can take a sample and always find the sample mean, so the sample mean is easy to find. So let's find the point estimate of the population mean mu. This example here is a social network website, and it represents the number of friends for 40 users of this website. We can easily find the sample mean of this website by adding up all the numbers, dividing by the number of numbers, and we get a sample mean of 130.8. So that's our point estimate, or our starting point, to find the interval that includes the true population mean, the true number of friends for all users. Now notice we just found that the point estimate was 12. If the point estimate was 12.4, we're not saying that the population mean is 12.4. What we're saying is the population mean is around 12.4, somewhere between this lower limit and this upper limit. So next we need to see how to find these limits to find the interval that includes the population mean, the unknown population mean. Right, the next thing we do, these are known as confidence intervals, so associated with this interval is a level of confidence. Now, the level of confidence, C, is always going to be in the middle because of the symmetry of this bell. What's left over here in these tails are 1 minus C divided by 2, right? Then we can use the standard normal table. So for example, suppose we're looking for a level of confidence of 90%. Well, if 90% is in the middle, then 10% is left over, right? 1 minus 0.9 is 0.1. Half of 10% is 5%, 0.05 in both tails. If we go to what we learned in section 5.3, we look in the body of the table for 0.05, and we find that this value down here is negative 1.645. By symmetry, this value up here is positive 1.645. So the corresponding z-scores are plus or minus 1.645 for a confidence level of 90%. And it will stay that way anytime we're using a confidence level of 90%. Now, the sampling error is really a theoretic current idea because it's the sample mean minus mu, but remember mu is unknown. So we really don't ever know the sampling error, but that's what the sampling error is. So we need to come up with another way of finding this difference, and that's known as the margin of error. The margin of error is the greatest possible distance between the point estimate and the value of the parameter, and this margin of error includes this given level of confidence. The formula for E, the margin of error, is that Z of C times the standard deviation of the X bar, which we saw in section 5.4, is the population standard deviation divided by the square root of the sample size. Remember, this is also known as the standard error of the mean. We saw this in section 5.4. But if we don't know the mean, remember we're doing this confidence interval because we do not know the population mean. When we don't know the population mean, we often do not know the population standard deviation. But if the sample size is large enough, And in statistics, large enough is generally at least 30, then the sample standard deviation can be used in place of the population standard deviation. And again, just like the population mean, we can always find the sample standard deviation. All right, so let's go back to our example. Remember that the sample, in this case, we're going to use a confidence level of 0.95. Well, 5% is left over. Half of 5% is 2.5, and 2.5% written as a decimal is 0.025. We look up 0.025 in the body of the standard normal table, and we get a value, a z-value of plus or minus 1.96. All right, so to find the margin of error then, we plug this into a formula. We had 1.96 for the critical value. Standard deviation, the sample standard deviation was 53. The sample size was 40, so the margin of error is 16.4. So we're 95% confident that the margin of error for the population mean is about plus or minus 16.4. Then to find the confidence interval, we just take the point estimate, which is the sample mean, and subtract the margin of error to get the lower limit, and add the margin of error to get the upper limit, and we think that the population mean is somewhere in between these two values. All right, so to construct a confidence interval, the first thing you need to do is find the sample mean. Then you find the sample standard deviation if it's not already given to you. Then find the critical values using the standard normal table. Recall, we've already found two of them. If the confidence level is 90%, then those critical values are plus or minus 1.645. And if it's 95%, the critical value is plus or minus 1.96. Then find the margin of error, and then add and subtract it from your sample mean, and you have your left and right endpoints for our confidence interval. Going back to our original example, remember that X bar was 12.4, and the margin of error was 16.4. So, I'm sorry, there's a mistake here. It's not 12.4, it was 130.8. So we add and subtract negative 16.4 and add 16.4, and we get our confidence limits, the lower limit being 114.4 and 147.2. So what that says is we're 95% confident that the population mean number of friends of all users, not just those 40, but of all users, is somewhere between 114.4 and 147.2. Let's look at one more example. Now let's construct a 90% interval for the average age of all students. So they took a random sample of 20 students, and they found the mean age of those 20 students to be 22.9. Now in this case, we don't need to use the sample standard deviation because it is known from a past study that the population standard deviation is 1.5. Now, remember a minute ago we already found the critical values for 90%. It's plus or minus 1.645. And now we find the margin of error, which is 1.645 times 1.5 divided by the square root of 20, which is approximately 0.6. We add and subtract that from the sample mean of 22.9, and we get limits of 22.3 or 23.5. So the average age of all of their students is somewhere between, we're 90% confident that it's somewhere between those two numbers. Right? Now, no, the population mean is a fixed number. We don't know it, but it's either in the interval or it's not. So we're not 90% confident that the population mean is exactly in our interval. Just that if a large number, if we did this 100 times, we expect the true population mean to be in 90% of them. Right? And what we're hoping for is that one of the intervals we have is one of these intervals that actually encompass the true mean, which is unknown. So we don't know if ours is one of these 9, or is it this one over here that does not. Kind of like when you use Consumer Reports to buy a new car. You don't know that your car is not a lemon just because 99% of all Honda Accord owners like their car, because there is still that 1% that do not, and your car could be one of these, but you're just hoping that the numbers are on your side, that your car is over here. So when we do a confidence interval, we're just hoping that our interval is one of these 9 intervals and not this 10th one. Sometimes we are given a margin of error. Often FDA has margin of errors that are acceptable. And so what you need to do is find the minimum sample size needed in order to achieve that particular given margin of error. So N needs to be at least the critical value times the standard deviation divided by the given margin of error and square that number, and then always round up. So let's find the minimum sample size. Suppose now we want to be within 7 friends. So that's the margin of error. It's usually when you're saying it in words, the margin of error, the given margin of error is usually after the words within some number, or if not the word within the words that mean the same thing as. So remember, we already found the critical value for 95%. It was plus or minus 1.96. So C of C is 1.96. The standard deviation was 53, and we said within 7 friends, that goes down here. 1.96 times 53 divided by 7, and then square that number, and we get 220.23. You always round up, because if we need 0.23 of another person in our sample, we need the whole other person in the sample. So we need to have at least 221 users for our sample, and in that case, our margin of error would be within 7 people, 7 friends. All right, that is the end of section 6.1. Please go to the Course Compass website and do the My Math Lab homework set for section 6.1.